Welcome back, students. We were studying different display devices. In that, we have studied LCD and TFT LCD. Now, we will see plasma display. What is the plasma display? Plasma display is a type of flat panel display that uses plasma and electrically charged ionized gas to illuminate each pixel in order to produce a display output. It is commonly used in large TV displays of 30 inches and higher. Plasma displays are often higher than LCD displays and also have a wider color gamut with black levels almost equaling dark room levels. Means it is used for the large TV displays more than the LCDs. Plasma displays are also known as gas plasma displays because we are using electrically charged ionized gas here. Plasma displays make use of ionized gases to create luminance as opposed to LCD technology, which uses a backlighting such as fluorescent and LED. This is used in LCD. Here, in the plasma displays, we are using ionized gases. Okay, a plasma display panel that consists of millions of tiny compartments that are sandwiched between two panels of glasses. It is having millions of tiny compartments. They are sandwiched between the two panels of glasses. Means just like the TFT, there are two panels of glasses, and in between that, the particular ionized millions of tiny compartments are sandwiched in between the two glasses. Each compartment or cell is arranged in groups of three, which are coated in phosphorus colored red, green, and blue. Electrodes crisscross along the cells front and back, and when a cell needs to be activated, the electrodes are charged. The voltage difference between the front and the back ionizes the gas in the cell, that is results in a loss of electrons and creating an electrically conducting plasma of atoms or ions and free electrons in that particular sandwiched in between the two glass nodes. The collision that happens because of the free floating particles, it leads to light emission with the color being dictated by the phosphor coating the cell. What does it say? It means that whatever the collision happens for in between the free floating particles, due to that collision light is emitted, and because of light is emitted, the color is being formed in between the different lights. The color is being formed, and we can see that on the display device. Apart from highlight and color are generated, the process of combining pixels and forming an image is similar to that of other display technologies. It is exactly equal to the other technologies, except that how light and colors are generated. Okay, because of the charge that is needed to ionize the gas in a panel, plasma displays run hotter and consume more power than the LCD and AMOLED panels. And although they are capable of faster switching, prolonging the display of a static images, which causes a burn-in phenomena where the image sticks to the display even after several refreshes. Means from all the discussion we can say that the plasma display, these televisions have wide screens comparable to the largest CRT sets, but they are only about 6 inches thick. In this section we'll see how, let's see how these sets do so much in a small spaces. It is only a 6 inch in thick, that is 15 centimeter. The basic idea of plasma display is to illuminate tiny colored fluorescent light to form an image. In plasma TV, they work by illuminating thousands of tiny fluorescent light to create an image. There are thousands of tiny fluorescent lights are generated, by that different colors are generated and an images form. Each pixel is made up of three fluorescent light, a red light, a green light, and a blue light. Okay, each pixel is made up of these three lights, and by the mixing of these three lights we are getting different colors and different images. Just like CRT televisions, the plasma display varies the intensities of the different lights to produce a full range of colors. Now let us see, the central element in a fluorescent light is a plasma. Okay, in the fluorescent light, central element is a plasma, a gas made up of free flowing ions, that is electrically charged atoms and electrons. They are negatively charged particles. Under normal condition, a gas is mainly made up of uncharged particles, that is the individual gas atoms. They include equal number of protons and electrons. The negatively charged electrons perfectly balance the positively charged protons. Okay, negatively charged electrons and positively charged protons, they perfectly balance each other, so the atom has net charge of 0. If you introduce many free electrons into the gas by establishing an electrical voltage across it, the situation changes very quickly. The free electrons, they collide with the atom, knocking loose to the other electrons. With a mission electron, an atom loses its balance. Okay, it has net positive charge, making it an ion. Which means that in a plasma with electrical current running through it, in that particular plasma, which plasma gas, in that plasma gas, electrical current that is running through it, negatively charged particles are rushing towards the positively charged areas of the plasma. Means negatively charged electrons are moving towards the positively charged area of the plasma, and positively charged particles are rushing towards the negatively charged area of the plasma. That's why they are balancing each other. In this particular rush, particles are constantly bumping into each other. They are moving towards each other. Positive charge are moving towards the negatively charged area, and negatively charged are moving towards the positively charged area. That's why these particles are constantly bumping over each other. This collision excites the gas atoms in a plasma that causes them to release the photons of energy. Xenon and neon atoms, they are used in a plasma screen. They release light photons. When they are excited, mostly these atoms release ultraviolet light photons, which are invisible to the human eyes, but ultraviolet photons can be used to excite the visual light photons. Means by using that ultraviolet light photons, the particular visible light photons can be excited, and by that visible light photons, human eye will be able to watch the full colored image over that particular screen. This is how a plasma screen works, or plasma display works. In this diagram, you can see the inside structure of the display, plasma display. In that, xenon and neon gas in a plasma television is contained in hundreds of thousands of tiny cells. They are positioned between two plates of glass. Here are two plates of glass, front plate of glass and rear plate glass. In between these two plates, that particular thousands of tiny cells are positioned between these two glasses. Long electrodes are also sandwiched between the glass plates on both sides of cell. We can see long electrodes on the this particular on the two sides of the glass plates. The address electrodes sit behind the cells along the rear glass plate. Along the rear glass plate, we can see in a yellow color, that is address electrodes. Okay, next to that, the transparent display electrodes. We can see display electrodes here at the upper side, dielectric layer. Below the dielectric layer, there is a display electrodes. They sit behind the cells along the rear glass these display electrodes, which are surrounded by an insulating dielectric material and covered by a magnesium oxide protective layer, they are mounted above the cells along the front glass plate. Means address electrodes are along the rear glass plate, and this display electrodes are along the front glass plate. Both sets of electrode, they extend across the entire screen. The display electrodes are arranged in horizontal rows along with the screen, and address electrodes are arranged in a vertical column. Okay, display address electrodes are for along the horizontal rows, and these display electrodes are for the vertical columns. When the intersecting electrodes are charged, an electric current that flows through the gas in the cell. As we can see here, the current that creates a rapid flow of charged particles which stimulate the gas atoms to release the ultraviolet photons. Here are UV photons are released by the surface of the display electrode and address due to the intersection of display electrode and address electrodes. The released ultraviolet photons, they interact with phosphor material coated on the inside wall of the cell. This is inside wall of the cell, that is blue colored wall, you can say. Phosphors are substances that give off light when they are exposed to the other lights. When an ultraviolet photon that hits the phosphor atom in the cell, one of the phosphorus electron, they jumps to the higher energy level and the atom heats up. Here all the atoms, they heats up. When the electron falls back to its normal level, it releases energy in the form of visible light photons. The main advantage of plasma display technology is that one can produce a very wide screen using extremely thin material. Okay, whatever the material of plasma display is extremely thin, but we can form a very wide range of image or display over the plasma display. And because each pixel is lit individually, the image is very bright and looks good from almost every angle. It is very clear from every angle. The image quality isn't quite up to the standards, means it is not good image quality, but it is very bright and sharp to the standards, to the best cathode ray tube sets. Whatever the image quality of cathode ray tubes, the same is not the image quality of this particular plasma display, but it certainly meets most people's expectations. The biggest drawback of this technology is that the price of the plasma display. However, falling price and advances in the technology mean that the plasma display may soon age out of the old CRT sets. It will be replaced by that particular CRT sets. The plasma displays are more like the monitors, and they need an external TV tuner to display the broadcast signal. TV tuner external is needed for the broadcasting purpose. Plasma displays are digital and have higher resolution than CRT. When shopping for plasma TVs, it is important to note that not all the plasma displays can produce a full resolution of HD TV. That's why we have to consider different resolutions. We can see some of the advantages and disadvantages of the plasma TV are that advantages are they have a large screen size, they have a slim profile, it is very thin, they can be wall mounted also, ceiling mounted also, or placed on a stand also. All these three options are available in case of this particular plasma TV. But the disadvantages of this plasma TV are they are relatively expensive, they are susceptible to burn-in, means it heats up that particular inside cover of the plasma TV and they can be burn-in. This can be avoided by lighting the length of the time that images stay on the screen, especially for the first few months of using the plasma TV. Okay, they have a poor black level. These are the disadvantages of the plasma TV. The next type of display device is a camcorder. A camcorder is a self-contained portable electronic device with video and recording technology as its primary functions. It is typically equipped with an articulating screen mounted on the left side, a belt to facilitate holding on the right side of the hand, hot swappable battery facing towards the user, and hot swappable recording media, and an internally contained quite optical zoom lenses. This is all the functions are available. All these functions are available in a camcorder. The camcorder can also be called as a handy cam, which can be held in a handy. Okay, these digital camcorder models offering HD resolution and multiple storage, that is HD memory card or HDD, have become the standard. In addition to the image processing, digital camcorders require various controls including flashlight, motor remote, flash memory for image recording, and USB interfaces also. Now let us discuss the next next digital display device, that is digital camera. Digital camera is a hardware device that takes photographs and stores the image as data on the memory card. Unlike the analog camera, which exposes film chemicals to light, a digital camera uses digital optical components to register the intensity and color of the light and converts it into the pixel data so that an image can be printed over there in the memory card. Many digital cameras are capable of recording video in addition to taking photos. Means it can be used for taking photos and taking videos also. Here, the digital cameras can do the film. Cameras cannot display images on a screen immediately after they are recorded, storing thousands of images on a single small memory device and deleting images to free the storage space. This is done in a digital camera. The majority, including most compact cameras, can record moving videos with sounds as well as still photographs also. Some can crop and stitch also the pictures and perform other elementary image editing also in this particular digital camera. Some have GPS receiver built in also and can produce a geotagged photographs also. The optical system that works at the same as in a film cameras, typically using a lens with a variable diaphragm to focus light onto an image pickup device. The diaphragm and shutter admits the correct amount of light to the imager, just as with the film, but the image pickup device is electronically rather than chemical. Okay, in other cameras it is chemical. Whatever the pickup device we are using, that is chemical. Here it is electrical. Most digicams, apart from the camera phones and few specialized types, have standard tripod screw also. Digital camera are incorporated into many devices ranging from PDAs in mobile phones to the vehicle. Now, let's see advantages of a digital camera. It is having an LCD screen. The rear mounted LCD screen on a digital camera allows user to see their photos and videos immediately after they are taken. The LCD screen that can also make it easier to frame your pictures. Storage. A digital camera that can store thousands of pictures instead of only up to 36 pictures. Picture development. In this digital camera, pictures can be developed like standard film camera, but you can pick which picture to develop instead of developing the whole roll of film. That is an advantage of this particular digital camera. Size. Because of digital camera does not have a place for film, not an SLR, it takes free far less space and can easily be carried out in a pocket or purse. This is all about the digital camera. Here ends the topic, that is display devices and second unit also.